Hi friends, see in electrostatics part 3, I think we discussed about different graphs about electric potential on a solid sphere, hollow sphere, E versus R graph in electric field intensity, and also potential versus radius graph also you have seen. Okay, now in part 4, because I told you this is also a little lengthy chapter, in part 4 today we will be discussing about the capacitance. What is meant by capacitance of a definition? Okay, part 4, that is, we will be discussing today about capacitance or capacitor. What is capacitance, and thereby what is capacitor or condenser? Okay, so today we will discuss about what is capacitor, what are the various formulas dealing regarding the capacitance. Okay, so let us start off with that one. Okay, we'll start. Let us start. Just wait, just a minute. Right. Now, in this part 4, we will discuss about, first of all, what is the capacitance or what is the capacitance or capacitor? Okay, what is the difference between capacitance and capacitor? Because condenser and capacitor are both same definition. Now, what is capacitance? Okay, for that what I will do is, I will take for example, a conductor. Let the potential, I told you in the before classes part 3, what is potential? Potential difference between P and Q be V, and let Q be the charge flowing in the conductor. Let Q be the charge flowing in the conductor. Now we will define in this fashion. Either you can use small q or capital Q, please. Any Q you can use. It is up to you. So what is the relation? See here. Q is directly proportional to V, or Q is equal to constant into V. That means the charge flowing in any conductor is directly proportional to the potential difference applied between the two conductors. Between the two ends of the conductor, P and Q. And if you remove that one, introduce a constant K. This constant K is called as C, and this C is called as capacitor condenser, and it is also called as capacitance. Okay, so Q is equal to CV, or Q by V is equal to C. Please observe carefully, this formula is very, very important in solving numericals, please. In solving numericals, it is very, very important. It is very, very important in solving numericals, please. Okay? So, ఇక్కడ ఏం జరిగింది? Q అంటే charge flowing in the conductor. V, potential. So, it can be defined as a ratio of charge to that of potential. So, what is the charge unit? Coulomb. Potential unit volt. So, 1 coulomb by 1 volt is equal to 1 farad. But what is a farad? Is a very big unit. So, better we will be using millifarads. Later on in the chapter goes, as the chapter advances, we won't use farad. Farad is a big unit. Okay, it is named after the scientist Sir Michael Faraday, great scientist. SI unit of capacitance. SI unit of capacitance. So, millifarad means 10 to the power of minus 3. Microfarad means 10 power minus 6. The same way, picofarad means 10 to the power of minus 12 farads. So, these are the things we will be using in future in this chapter. ఎప్పుడైనా నేను 10 పవర్ మైనస్ 3 వచ్చింది అంటే దాన్ని మిల్లీ ఫ్యారడ్ అని అర్థం. 10 పవర్ మైనస్ 6 వచ్చినప్పుడు మైక్రో ఫ్యారడ్, మైనస్ 12 వచ్చినప్పుడు పికో ఫ్యారడ్. Because farad is a very big unit. We can't use that units as you have used in the before chapters. So the definition goes like this: ratio of charge to that of the potential of a conductor is nothing but capacitance. Okay, and This capacitance does not depends upon these two, please make a note. Capacity, because it is the formula giving us Q is equal to CV, means Q depends upon Q, doesn't depends upon Q and V. So, but what factors Q or C depends? Now let us try to explain that one. C దేని మీద ఆధారపడి ఉంటుంది? ఈ ఫార్ములా చూసి చాలా మంది Q మీద V మీద ఆధారపడి ఉంటుంది అనుకుంటారు. కాదు. Capacitance of a conductor does not depend upon the charge and V. So it depends upon what? That I will derive now and explain. So capacitance mainly depends upon the material and medium, please. Okay, I will tell you now and explain also. దేని మీద ఆధారపడి ఉంటుందంటే it depends upon the material, size of the material. Okay, and that is circular shape or metallic shape or whatever. It depends upon the size of the material. And second one mainly medium. Okay, what type of medium? It is in absolute medium or any other medium, free space, okay, or air. So it depends upon the medium. Already we discussed here epsilon is equal to epsilon naught r. Okay, we have given a relation also, epsilon naught r. That means epsilon permittivity of the medium, absolute medium, and epsilon naught free space or air, okay, or vacuum. So in air or vacuum, epsilon naught r, which is also called dielectric constant, sometimes it is also called a dielectric constant K, it is taken as 1. అప్పుడు ఏమవుతుంది? epsilon naught medium is equal to epsilon naught. Or from this equation, epsilon by epsilon naught is equal to K or epsilon naught r. This is what? Medium. This is air. Okay? Naught means what? In air. Epsilon, free space or air. This is absolute medium. Absolute medium, this is air. Right. Now we will try to explain these two conditions. Okay, why it is dependent upon material size and also the medium. See, in previous class in part 3, I have discussed about electric potential on a spherical conductor. For example, this is a conductor, sphere, carrying some charge plus Q. Suppose this is having radius capital R. This is center. This is spherical conductor. Already we have discussed regarding this one in the previous class. Potential is equal to KQ by R, either on the surface or center. Inside or outside, same value I have taken. Already I have drawn the graph also regarding part 3 of electrostatics. So potential on the surface or inside is given by KQ by R. Or this K, already I told you, it is nothing but 1 by 4 pi epsilon naught into Q by R. Clear? But just now I given what is Q? Q is equal to CV or Q by V is equal to C. Therefore, Q by V, what is V from here? KQ by R. Okay, R will go to the top. So therefore what happens? R by K is equal to C. R is the radius, that is material size. Okay, K 1 by 4 pi epsilon naught, which is equal to C. It will go to the top. So finally what happens to C value? Capacitance 4 pi epsilon naught R. This formula is very, very important. 4 pi is constant, epsilon naught medium, permittivity of free space. Okay, permittivity value కూడా తెలుసు కదా, 8.85 into 10 to the power of minus 12 coulomb square per Newton meter square. Okay, its value is given. So what happens here? C is depending upon what? Medium and also the material, not on the charge and potential, please. So this proves, okay, that the capacitance of a conductor depends upon the medium. If medium changes, capacitance changes. If the material size changes, radius, then capacitance are directly proportional. So this is how it is depending upon the material size and the medium, where epsilon naught is the permittivity of the free space. Okay, please note down, and this formula I will be using in future in next numericals and other explanations. So the capacitance of the conductor is given by what? 4 pi epsilon naught R. Okay, this formula you have to remember in your brain. C is equal to 4 pi epsilon naught R. C is equal to 4 pi. Capacitance of a conductor is given by 4 pi epsilon naught R. 4 pi epsilon naught R. This is medium, free space, permittivity and radius. So if the size increases, material size, capacitance also increases. And if medium changes, capacitance also changes. That will be dealing in the next coming topics. Clear? So this is the story about capacitor, capacitance or condenser. Okay? Now let us go still further after learning about these things. Okay? After learning about these things, shall we do one thing? Shall we do one numerical regarding this one? Capacitance. I'll try to give my own. For example, there are small problem, numerical. Small problem. For example, there are 27 drops, spherical drops. Okay. For example, there are 27 spherical drops. Okay. 27 into 27 I can't draw here, but I'll show 27. Okay, like this. 27 drops are there. Okay. And these are combined to form a big drop, for example. These 27 spherical drops of radius, for example, say small r. Okay. This radius, small r is also given, for example, take 3 mm, 3 millimeter, that means 3 into 10 power minus 3 meters. Just I am giving an example to solve the problem clearly. Okay. 27 drops are there, spherical drops. So each of radius in the 3 millimeters. 3 millimeters means 3 into 10 power 3 minus 3 meters. Okay. 3 millimeters. 1 millimeter enta? 1 millimeter is equal to 10 power minus 3. 3 means 3 into 10 power minus 3 millimeters. So each drop యొక్క radius ఇది. This is combined. ఇలాంటివన్నీ combine అయిపోయి it has formed a big drop, for example. This is a big drop. Now let this radius be capital R. Okay. Let this charge be capital Q and let this charge be V. And let the charge of this each drop be small q. Charge of each drop. Okay. Small q. And for example, let us say this value is, say, q is equal to around 10 power minus 12 coulombs. Anukundam. Let us assume. Let the charge of each sphere is 10 to the power minus 12 coulombs. Now the question is, what is the big drop? What is the big drop charge and also potential V? Or what is the big drop capacitance and the potential? Now in such cases, how you will solve this typical problem? So here you can apply the conservation of volume and conservation of charge. Conservation of charge and because ఇలాంటి బిగ్ డ్రాప్స్ 27 బిగ్ డ్రాప్స్ కలిపి ఒక పెద్ద డ్రాప్ ఫామ్ అయింది అంటే దిస్ వాల్యూమ్ ఈజ్ ఈక్వల్ టు దిస్ వాల్యూమ్. సో యూ కెన్ అప్లై లా ఆఫ్ వాల్యూమ్స్ అంటే కన్జర్వేషన్ ఆఫ్ వాల్యూమ్. దిస్ వాల్యూమ్ ఈజ్ ఈక్వల్ టు దిస్ వాల్యూమ్. ఓకే. వాల్యూమ్ ఇనిషియల్ ఐ కెన్ రైట్ లైక్ దిస్. వాల్యూమ్ ఇనిషియల్ ఈజ్ ఈక్వల్ టు వాల్యూమ్ ఫైనల్. Volume initial, that means this 27 drops volume is equal to volume of the big drop. This is called conservation of volume. You can apply this formula. కన్జర్వేషన్ ఆఫ్ వాల్యూమ్. అప్పుడు ఏమవుతుంది, ఈ వాల్యూమ్ ఎంత మొత్తం స్పియర్ కదా, 4/3 పై స్మాల్ ఆర్ క్యూబ్ ఇంటూ ఎన్ని డ్రాప్స్ ఉన్నాయి, 27 డ్రాప్స్. దిస్ వాల్యూమ్ ఇస్ బికమింగ్ ఎ బిగ్ డ్రాప్. సో కంబైన్డ్ కాబట్టి 4/3 పై ఆర్ క్యూబ్, 4/3 పై 4/3 పై. సో ఇక్కడ ఏం మిగిలింది, ఆర్ క్యూబ్ ఇంటూ 27 is equal to r cube, or taking 1/3 on both sides, mathematically taking 1/3 on both sides ఏమవుతుంది, ఇక్కడ r power 3 1/3, 27 అంటే 3 cube power 1/3. Here 3 and 3 gets cancelled. So here also 3 and 3 get cancelled. ఏం మిగిలింది ఇక్కడ మనకి ఫైనల్గా, I'll write it here, r small r, ఇక్కడ కూడా చూడండి 3 cancelled, into 3 is equal to capital R. Are you following here? R cube, AB, loss of integers, AB power m, A power m, B power n. So R cube 1/3, 3 cancel, 3 cube 27 kada, 3 cancel. So 3 small r is equal to capital R. కానీ వాడు ఏం చేశాడు, ఆల్రెడీ రేడియస్ ఇక్కడ ఇచ్చాడు. ఎంత స్మాల్ r, 3 into 10 power minus 3 into as 3 capital R. So 3 is how much, 9 into 10 power minus 3 meters becomes the capital R. So this is the radius of the big drop now. How much, 9 into 10 power minus 3 meters. Clear? Please copy it. Now we'll apply law of charges. Copy it. Right. Now we got the radius of the big drop now. Okay, radius of the big drop వచ్చింది. ఇంకా మనకి ఏం కావాలో చూద్దాం one by one. We got the radius of the big drop. Radius of the big drop వచ్చింది కదా, big drop radius, center R. Now suppose if you apply law of charges, conservation of charge before and after, ఇక్కడ ఎన్ని ఉన్నాయి, 27 into small q is equal to big drop, charge తెలీదు. ఓకే, 27 drops, అదే అదొక పాయింట్ మీకు. సి we know q is equal to cv. This is the charge value of big drop. What is charge value of small drop, small q. సో ఎన్ని చార్జెస్ ఉన్నాయి మొత్తం, 27 చార్జెస్ ఉన్నాయి, 27 డ్రాప్స్ ఉన్నాయి. 27 ఇంటూ చార్జ్ వాల్యూ. ఓకే, 27 ఇంటూ స్మాల్ చార్జ్ ఎంత, 10 power minus 12 coulombs. This is capital Q. Now if you want the value here, the capacitance of this one, you can calculate. Q is equal to CV, or Q by V is equal to C. Q by V is equal to C, లేదా Q by C is equal to V. ఎందుకంటే we know already C value, 4 pi epsilon naught into R, 4 pi. See here one technique you have to use here, please make a note, I'm telling you. Q is equal to CV. If you want V, what happens, you divide Q by C. Okay, but I will calculate C. Q by V is equal to C. Q already మనకి ఎంత తెలుసు కదా, ఎంతది, 27 into coulombs by what is V, సారీ C కదా క్యాలిక్యులేట్ చేస్తున్నాం మనం. C ఆల్రెడీ తెలుసు కదా, ఎంత, 4 pi epsilon naught. చూడండి 4 pi. See we already know from Coulomb's law, 1/4 pi epsilon naught is equal to 9 into 10 power 9, లేదా 1/9 into 10 power 9 is equal to 4 pi epsilon naught. So in the place of 4 pi I can put this value 9. అదొక పాయింట్ ఇక్కడ. Here I'll change this formula for you. We'll try to calculate V. Q by C, Q is equal to C kada, Q by C is equal to V. Q is equal to CV kada. So Q by C, C anta 4 pi epsilon naught enta, 1/4 pi epsilon naught means 9 into 10 power 9, లేదా 1 by 10 is 4 pi. And 1 by 9 into 10 power 9 is equal to 4 pi into R. What is R here? Is just now calculate 9 into 10 power minus 3 meters. So you can take it top, or here also you can cancel. Like this, so better not to confuse. So Q by C V, that is equal to 27 into 10 power minus 12. This one to the top, 9 into 10 power 9 by denominator 9 into 10 power minus 3. This 9, okay. This 10 power minus 3, if you take top, what happened? Plus 3 and 9 plus 12. Plus 12 minus 12, both will be cancelled. So what is left over? 27. So that is 27 volts. So what is the potential value? What is the potential value? Potential value is equal to 27 volts, please. Okay. So the question is, he's asked you to calculate the potential of the drop. Big drop. So big drop your potential in the 27 volts. Clear? And if you want capacitance, you can apply this formula, you'll get capacitance value also. Because already you know the value, 4 pi epsilon, R value kuda telusu. 4 pi epsilon value kuda telusu neeku, 1 by this thing. Okay na? You'll get that value also. So like this, we'll be calculating for different types of numericals. Please make a note, try to understand the concept, then only you will get the value. అర్థమవుతుందా? మీకు కెపాసిటెన్స్ కావాలన్నా కూడా కట్టచ్చు. సి ఎంత? 4 pi epsilon నాట్. ఎందుకంటే అర్థమైంది కదా, 1 by 4 pi epsilon అంటే 9 కదా. 1 by 4 pi epsilon is equal to 9 into 10 power 9. సో 1 by 9 అంటే 1 by 9 into 10 power 9 into R. 9 into 10 power minus 3. 9 cancel, పైకి వెళ్ళిపోతుంది, minus 9 అంటే minus 12. 10 to the power of minus 12 farads. See, but just now I told you 10 to the power minus 12 means what? Picofarad. So C is equal to 1 PF. Clear? So this is the capacitance of the big drop, 10 to the power of minus 12 farads or 1 picofarad, and potential is 27 volts. Like this you have to solve it. Okay, right. Now let us go to the next concept in this one. So I told you it's a concept plus numericals, very very important. In this electrostatics, you have to know concept as well as you have to do problems. Now let us go to the next one in this version, that is energy stored in the capacitor, please. Okay, energy stored. Next one is energy stored in the capacitor or condenser. Okay. So generally the energy stored, you have an IP derivation, 4 marks. See, whenever required only I am doing derivations, otherwise I will give direct formulas. So for energy stored E or U in the capacitor, generally we have 3 formulas. One is in the form of half CV square. This is the first formula. Second one, you can change this one because you know what is Q CV. So you can put here second formula for this one, energy stored E or U is equal to half into CV square. I can write as C into V into V. So that is equal to half into, what is CV? Q is equal to CV. I can put capital Q into V. Therefore, QV by 2. This is the second formula for energy stored. Third one, E is equal to U is equal to in half CV square. From this I will try to calculate what is Q by C. Q by C is equal to V. Put it here. Okay, into C into V square and Q by C whole square. Therefore energy stored U or E is equal to half into C into Q square by C square. So finally Q square by 2C. So these 3 formulas you have to use as and when required according to the requirements. Either half CV square or QV by 2 or Q square by 2C. In terms of charge and capacitance, capacitor, in terms of, suppose ఇప్పుడు మీకు charge potential ఇచ్చాడు, use this one. charge capacitance ఇచ్చాడు, use this one. Capacitance and voltage ఇచ్చాడు, use that above formula. Like that you have to utilize the formulas, please. Okay, clear? QV by 2 half CV square Q square by 2C. These three formulas are very very important while solving numericals. So that is regarding the energy stored. Okay, now let us explain charge distribution in the parallel plates. So parallel plates lo charge distribution ఎలా జరుగుతుంది? Okay, charge distribution in the parallel plates. Okay, charge distribution in the parallel plates. For example, let us try to understand the subject. These are two parallel plates, 1 and 2. Okay, now how the charge is this? For example, ఈ charge ni మనం ఏం చేద్దాం, Q1 అనుకుందాం. Let us assume this charge as Q1 and this plate as Q2. Now how? రెండే కాదు, you can even take 3, 4, 5, 6, n number of plates, n number of parallel. You can take n number of plates, n number of parallel plates. If such condition is given, how to get the outside value and inside value? See, outside charge value is got by the formula, very simple. Add up how many charges are there. If 2 are there, Q1 plus Q2 by 2. 3 are there, Q1 plus Q2 plus Q3 by 2 only. It is not average, please. Okay, so add up all the values by 2. Okay, so number of charges by divided by 2. Suppose 10 charges ఉన్నాయి, Q1 plus Q2 plus Q3 plus so on up to 10 by 2 only, not by, it's not average value. So here what happens, the value outside will be Q1 plus Q2 by 2. So here the outside value antidi Q1 plus Q2 by 2. So here also what is the outside value, Q1 plus Q2 by 2. So what will be inside now? Balance అవ్వాలి, outside value ఇది. So inside ఎంత వస్తుంది? Subtract Q1 minus Q1 plus Q2 by 2. This will be the inside value. Okay, so if you take LCM, 2Q1 minus Q1 minus Q2 by 2. So 2Q1, Q1 ఎంత అవుతుంది? Q1 minus Q2. So ఇటుపక్క వాల్యూ ఎంత అవుతుంది? వాల్యూ ఇన్సైడ్ Q1 minus Q2 by 2. This is the value here. But without seeing, I can write this value here. Opposite ఇక్కడ ఉంటుంది, లేదా ఇక్కడ ఆల్సో క్యారీ. ఆపోజిట్ ఎంత? దిస్ వాల్యూ డైరెక్ట్లీ I can tell you. Q1 minus Q2 by 2. Sorry, Q2 minus Q1 by 2. ఎలా వచ్చింది చూడండి, చూపిస్తాను. ఓకే, సో దీనికి ఆపోజిట్ ఏంటి? దీనికి మైనస్ పెట్టండి. మైనస్ అంటే Q2 minus Q1 by 2. లేదా యూ క్యాన్ యూజ్ దిస్ ఫార్ములా. ఇక్కడ అవుట్ సైడ్ వాల్యూ ఎంత? Q1 plus Q2 by 2 is the outside value for this plate. So what will be the inside? This total value minus Q1 plus Q2 by 2. Once again, if you take LCM, 2Q2 minus Q1 minus Q2 by 2. 2Q2 minus Q1 ఎంత అయింది? Q2. Q2 minus Q1 by 2. See, same value. So please remember this one as a formula whenever two parallel plates are given in capacitors. Okay, outside value, okay, whatever value is nothing but number of plates divided by 2, outside value, and inside this value minus this one. Okay, in the same way, inside values of two plates will be opposite sign. If the plus unte minus, if the plus charge aithe minus will be having. Okay, if the plus Q aithe minus Q avutundi, because from these things. These are very very important, please copy it. Clear? Right. So this is how the charge is distributed in the parallel plates. If many plates are there, n number of plates, add up all the values of the plates with sign convention. With sign, adding up means with the sign, plus minus, and divided by 2. Okay? So like that you will be getting the charge inside and outside. Now let us see a small diagram regarding parallel plates, regarding the relation of, see, same parallel plates, we will find a relation for sigma. What is sigma actually? Charge density. Charge density means, you know, charge divided by area. Okay? What is charge density? Charge divided by area is called as charge density. If one plate is positive, it will be positive. Another plate negative means minus and plus. Plus sigma, minus sigma, depending upon the charge. Positive charge unnappudu, positive sigma. Negative charge unnappudu, negative sigma. Now let us see between parallel plates how the charge is distributed. For example, these are two parallel plates. These are two parallel plates. Okay. For example, this is plus Q and this is minus Q. Just now I told you what is the outside charge? Q plus Q1 plus Q2 by 2. And Q plus Q minus Q by 2. So 0 by 2. So outside charge is 0. So ఇక్కడ ఎంత అవుతుంది అప్పుడు Q minus 0, Q plus charge ఇది. So from that concept becomes plus. అలాగే outside charge ఇది కూడా 0 కదా. Okay, same value you will be getting 0. So what will be the inside value? This minus this thing, and minus Q minus 0, that is minus Q. So this is negative charge. So as we know how the field will be going away from the positive charge. So this is how the field will be there. I told you in the before chapter. This is the field direction. Field will be towards negative charge and away from the positive charge. Okay. So this is all. Let the distance between them is plates be D. And please make a note, this distance D should be very less value as compared to the plates. Okay. The distance and the D and D should be very small value as compared to the plates, as compared to the parallel plates. So this is how you can explain the charges and other thing. And we have a relation also when D is the distance between the two parallel plates, and if charges are plus Q and minus Q, we have one formula for capacitance. I am not deriving and giving the formula because of, I told you, mainly we are concentrating. If you want the derivation, you can derive by using the general formulas. Q is equal to CV, and also in before classes I have derived some equations also. See, in before classes, this is the parallel plate annam. Parallel plate ante infinity plate. Ante infinity sheet ki samanam. Parallel plate ante infinity plate. Infinity sheet ki meeku already derived chesin sigma. Entadi? Sigma, field. Field is equal to sigma by 2 epsilon naught. Already I have derived an equation before classes. E is equal to sigma by 2 epsilon naught. So if you observe carefully, field is coming towards the field is coming towards the negative, and one another field again going away. So E1 and E2. So what is the net field? E1 plus E2. Electric field goes away from positive and comes towards the negative. So both charges E1 and E2 at a particular point are coming towards same direction. So what is E net? E net will be E1 plus E2. E1 plus E2 and 2 sigma by 2 epsilon naught 2 times, that is sigma by epsilon naught. 2, that is the E net, same direction. Opposite direction is the minus charge. Okay. So that is the value E net, same direction but you are adding. And by using these formulas, you will be getting capacitance formula as epsilon naught A by D. That means now you are observing capacitance does not depend upon charge and voltage. It depends upon the size, area of the plates and the distance. Directly proportional to area, inversely proportional to distance between the plates. So this formula also will be using in future. And epsilon naught, you know, the medium value, free space, 8.85 10 power minus 12 coulomb square per Newton meter square. It's a medium value, not, okay, free space or air. Clear? So this formula you will be using in future, the relation between capacitance, area and distance between. Okay? By using these formulas, we will be deriving all those. Okay? Clear? Right. I am going to the next one now. Okay? Now let us go, after learning about this relation, let us see what is energy density. The next one, let us learn about what is energy density and energy density of the parallel plates and ENT. Let us see about the what is energy density. Just now I told you energy density of the parallel plates. So same as usual, when two plates are taken, ఒకటి ప్లస్ ఒకటి మైనస్ అయినప్పుడు ఇప్పుడే చెప్పాను కదా, ఈజీ అయిపోయింది సబ్జెక్టు. Q1 ప్లస్ Q2 బై 2 నెంబర్ ఆఫ్ ప్లేట్స్ డివైడ్ బై 2 ప్లస్ 0 అయిపోతుంది. ఇన్సైడ్ ఎంత అవుతుంది? ప్లస్ ఇది కూడా సేమ్, అవుట్ సైడ్ 0, ఇది ఎంత అవుతుంది? మైనస్. అండ్ ఫీల్డ్ విల్ బి ఫ్రమ్ ఆల్వేస్ పాజిటివ్ టు నెగిటివ్. Field direction, this is direction, goes always away from the field towards the negative field, away from the positive towards the negative. ఇక్కడ ఎనర్జీ డెన్సిటీ ఎలా డిఫైన్ చేస్తాం? ఎనర్జీ డెన్సిటీ మీన్స్ ఎనర్జీ పర్ యూనిట్ వాల్యూమ్, U by V or E by V, energy. Okay, energy stored divided by volume. Already energy I have given in different forms, half CV square or Q square by 2C or QV by 2. Check చేసుకోండి. CV into V, QV by 2. Different forms I have told you. Energy stored. Now this energy, if you divide with V or unit volume, you are getting energy density. What is energy density? Energy per unit volume. Suppose if you take this first formula, అనుకోండి అందరికి. Suppose if you take the first one, any formula you can take depending upon the requirements in the formula. So energy density, I'll take first formula of C V square. So this equation I can change. What is C from previous class? That is just now. C is equal to epsilon naught A by D. In terms of area and distance, I mean distance between 2 points. So I can write as half C plus rho epsilon naught A by D into V. This V is making a voltage, potential. But we know already what is V. V is equal to ED. Take magnitude please, okay? Actually V is equal to minus E dot D or E dot R. But when you take in terms of magnitude, what happens? V is equal to ED. And please make a note why I am taking ED here. See here. E is direction in this direction. And distance also you can see distance. Distance also same direction. Distance and E both are same. See. Distance and E. Both. What is the angle between them? 0. So, even if you calculate the dot product E dot D, what happens? Mod E, mod D, cos 0. Cos 0 is equal to 1. Dot product of the two vectors. So, same direction kabatti E into D also same value. So, put the value there. Put the value there. What happens? So, finally, energy density, that is energy per unit volume, okay, is given by half epsilon naught A by D. In the place of V, what I will put is ED whole square, because V is equal to E into D. So finally what happens? Energy per unit volume, okay, is equal to half epsilon naught A by D E square D square. 1D gets cancelled. So finally half epsilon naught A, okay, ఇంకేముంది E square into D. Here I'll rub this V because till now you are not told about V. Energy అవుతుంది ఇది. Still you are going for energy only here, okay. So energy is equal to, ఇక్కడ కూడా అని ఇంకా వాల్యూమ్ అప్పుడే రాలేదు మనం ఎనర్జీ డెన్సిటీకి. సో ఎనర్జీ ఏమైంది హాఫ్ ఎప్సిలాన్ నాట్ ఏ ఈ స్క్వేర్ ఒక డీ క్యాన్సిల్ ఇంకా ఏరియా ఇంటూ లెంత్. వాట్ ఈజ్ ఏరియా ఇంటూ లెంత్? వాల్యూమ్, ఓకేనా. సో ఎనర్జీ ఫార్ములా ఫైనల్గా ఏమైంది? ఎనర్జీ ఈజ్ ఈక్వల్ టు యూ గాట్ ఇట్ యాజ్ హాఫ్ ఎప్సిలాన్ నాట్ ఈ స్క్వేర్ ఇంటూ వాల్యూమ్. Volume, area of the plates into distance. So this is what energy. Energy per volume and energy density. So divide by volume now. Divide by volume. So volume gets cancelled. The formula is nothing but half epsilon naught E square. This is the energy per unit volume. Very very important. Energy per unit volume. ఎనర్జీ యూనిట్స్ మీకు ఎక్కడైనా ఒకటేనండి, జౌల్స్ పర్ వాల్యూమ్ అంటే మీటర్ క్యూబ్, జౌల్ పర్ మీటర్ ఎస్ఐ యూనిట్. ఎనర్జీ ఎక్కడైనా ప్రెస్కాట్ జౌల్, వాల్యూమ్ అంటే మీటర్ క్యూబ్. సో దిస్ ఈస్ ద ఫార్ములా యూ హావ్ టు రిమెంబర్ అండి త్రూ అవుట్. ఎనర్జీ పర్ వాల్యూమ్, ఎనర్జీ మీన్ దిస్ ఫార్ములా, ఎనర్జీ ఇన్ ది కెపాసిటర్ ఏది హాఫ్ ఎప్సిలాన్ నాట్ ఏ ఈ స్క్వేర్ ఇంటూ డి. ఎనర్జీ పర్ వాల్యూమ్ బికాస్ ఎనర్జీ డెన్సిటీ ఆర్ వాంట్, డెన్సిటీ కావాలి మన ఎనర్జీ డెన్సిటీ, డివైడ్ బై వాల్యూమ్. So half epsilon naught E square, okay, half epsilon naught E square. Let us go to the next one. Clear all of you? Now let us calculate what is the force between the plates. Next one, let us calculate the force between the plates please. Next one, plates మధ్యన force ని ఎలా calculate చేయాలి? We'll try to see by using the formulas, okay na? Next one is force between the plates of parallel plates. Force between the parallel plate capacitors. So what will be the force acting? Let us try to explain. Okay. So let us take same two plates. Okay, one is, I told you, plus minus. Okay, if you take plus 0 outside, positive q minus 0, అలాగే ఇది minus q minus 0, ఇది minus charge అవుతుంది. Plus charge and minus charge, same thing I am taking కదా. Plus q minus q, outside the value is 0. సో ఇక్కడ వాల్యూ ఎంత ఉంది? దిస్ మైనస్ దిస్, ఇక్కడ దీనికి ఆపోజిట్ సైన్ ఇది. సో ఫీల్డ్ యూ నో ద డైరెక్షన్ ఆల్వేస్ అవే ఫ్రమ్ ద పాజిటివ్ చార్జ్. Field direction will be always from away from the direction of the field, positive, and towards the negative charge. Now how to how to calculate the force acting? Already just now you are given what is field from infinity sheet, sigma by 2 epsilon naught. Already I derived in the last part, in part 3 I think, okay. So sigma charge density by 2 epsilon naught, that is the field direction value. Okay, now what is force acting? F is equal to EQ. F is given by E into Q. Clear? F is equal to E into Q. I put 0 here, outside value. So now what happens? F force acting, F is equal to E into Q. Q is the charge. Okay? F is equal to E into Q. But what is Q? Q is equal to CV kada. Okay? What is Q? See here. I'll write here. Q is equal to CV. Okay? Q is equal to CV. Let us try whether that one is useful or not here. So force is equal to sigma by 2 epsilon naught into Q. Okay? Sigma by 2 epsilon into Q. Now what I'll do is we'll try to change this formula slightly so that we have to get the standard form. Okay na? So ఇక్కడ జాగ్రత్త అర్థం చేయండి. We already know what is C, between parallel plate, C is equal to epsilon naught A by D. Okay na? C is equal to epsilon naught A by D. Okay na? ఇది ఏమైనా యూజ్ అవుతుందేమో మనం చెక్ చేద్దాం. C is equal to epsilon naught A by D. We'll try to put this formula here. Q is equal to CV. సో ఇక్కడ మనం ఏమొచ్చింది, మనకి సిగ్మా బై 2 ఎప్సిలాన్ ఇంటూ క్యూ వచ్చింది. ఓకే, అదేవిధంగా దిస్ ఫార్ములా యూ కెన్ సీ, ఇందాక మీకు రిలేషన్ కూడా చేశాను కదా, ఏంటది, జస్ట్ క్రాస్ మల్టిప్లై దిస్ వన్, జస్ట్ క్రాస్ మల్టిప్లై. క్యూ స్క్వేర్ బై, రైట్, ఒకసారి నేను గమనించండి ఈ ఫార్ములాని. సి ఇంటూ డి ఈజ్ ఈక్వల్ టు ఎప్సిలాన్ నాట్ ఏ. ఓకేనా? ఈ ఫార్ములా ఏదో మనకి ఇక్కడ యూజ్ అవుతుందేమో చెక్ చేద్దాం. ఇక్కడ క్యూ అంటే సివి. ఓకేనా? క్యూ అంటే సివి మీన్స్ ఇఫ్ యూ పుట్ ఇట్ దిస్ వాల్యూ సి ఎప్సిలాన్ నాట్ ఏ బై డి ఇంటూ వి, because Q is equal to CV kada. Suppose if you put this value, is it any useful? Let us try. 2 by 2 epsilon naught, epsilon naught, epsilon naught. Okay? So it is not useful. Even if you apply that formula, it is not useful. Why I am telling is, we are trying to calculate the force here. Ikkada field is towards, away from the positive charge and towards the negative charge. And we are trying to calculate force equal and unlike forces. One force will be this side, another force will be this side. Newton's third law again will be coming into picture. That's the point. Positive charge వైపు force ఇటు వైపు, negative charge opposite to the field ఉంటుంది. మీకు అర్థమవుతుందా? ఫీల్డ్ ఇటువైపు ఉంది, డైరెక్షన్ towards the positive charge, negative charge. సో ఫీల్డ్కి ఆపోజిట్ డైరెక్షన్లో ఫోర్స్ ఉంటుంది. ఇక్కడ ఈ డైరెక్షన్, along the direction of the positive charge. So two equal and unlike, two forces are acting in opposite direction here. So ikkada force manaki em vachindi final ga sigma by 2 epsilon naught into q vachindi. So check cheyandi okasari. Okay, finally we got it as, okay, sigma by 2 epsilon naught into q, and we are getting finally in terms of d and d, in terms of d. Let us check up okasari ivanni ikkada apply cheddam. Nothing problem. F is equal to sigma by 2 epsilon naught Q ante CV. So F is equal to, okay, sigma by 2 epsilon naught C. What is C here? Epsilon naught A by D into V. ఓకేనా? సో ఏమొచ్చింది నాకు, సిగ్మా ఏవి బై డి ఫార్ములా తయారైంది ఇక్కడ. ఓకే, బికాస్ సి ఈజ్ ఈక్వల్ టు ఎప్సిలాన్ నాట్ ఏ బై డి, సి ఈజ్ ఈక్వల్ టు ఎప్సిలాన్ నాట్ ఏ బై డి, and from that CD is equal to CD by A is equal to epsilon naught. In this CD, we can చూడండి, from this CD by A is equal to epsilon naught CD by A. So let us put that form also here better. CD by A ఆ ప్లేస్లో పెడదాం మనం. ఓకేనా? Sigma, that is sigma by 2 epsilon naught. So this one can we write in this fashion? Sigma into q by 2 epsilon naught ni can I write in this fashion? Q square by 2a epsilon naught, Q square by 2a epsilon naught. Can I write the formula like this? F is equal to Q square by 2a epsilon naught. ఈ విధంగా రాయొచ్చా? చెక్ చేసుకోండి. ఫ్రమ్ బై యూజింగ్ దీస్ ఫార్ములాస్. C is equal to epsilon naught A by D. And I am removing the term. ఈ టర్మ్స్ మొత్తం రిమూవ్ చేస్తున్నాను, ఎప్సిలాన్ నాట్ వగేరా అంతాని. ఓకేనా? సో I can write like this, isn't it? Now from this what happens finally? Force. Finally what happens? Because C is equal to epsilon naught A by D. So from that what? Substitute that value here. So when you substitute, finally what happens? You are getting half CV square. Half CV square by D. Okay? Okay? CV square by 2D లేదా half CV square by 2D. So this is the force acting. When you substitute the value, you are getting CV square by 2D because Q is equal to CV. Substituting here in this equation, finally ఎంత ఫోర్స్ పనిచేస్తుంది దీని మీద? ఈక్వల్ ఆపోజిట్ టు CV square by 2D. CV square by 2D. Please make a note of that one. So as I told you, derivations we are not interested here because mainly concentrate on the formulas. Those are important for MSET, please. Clear? Right. So finally a force ఎంత యాక్ట్ అయింది ఇక్కడ? half CV square. Okay? So that is equal opposite direction. Newton's third law. Each side of force అటువైపు. So two forces are acting in opposite directions. Okay? CV square by 2D. Now let us go to the next cases. Special cases and ivi. These are special cases. These are special cases. First one is spherical capacitor. Spherical capacitor with unequal radius or diameter. So in the case of this one, what happens is, first one is area, radius small a, and outside one radius is small b. Let us take the radius as a and b. And here what I'll do is, inside I'll take positive charge, inside I'll take positive charge sphere, okay, and this one I'll take negative charge. Okay, one is plus and one is minus as usual. This charge is minus and this is plus q. And radius are a comma b. Okay, radius of b, this radius is small a. In such cases, for example, if they ask for special cases, that is, what is the capacitance of spherical capacitor? So in such cases, capacitance is given by C is equal to 4 pi epsilon naught into AB by A minus B. 4 pi is constant, epsilon naught, you know it's a constant, 8.8 for 10 power minus 12. A comma B are the radius of the spherical surface, okay? Outer surface and inner surface. So ఈ ఫార్ములా గుర్తుపెట్టుకోండి. In special cases ఎప్పుడైనా ఎగ్జామినేషన్లో what is the capacitance of the spherical object with different diameters A and B? 4 pi epsilon naught AB by A minus B. It's not B minus A, please, sorry. It's not A minus B. Okay, B is the bigger diameter now. So B minus A, please. B పెద్దది కదా A కన్నానే. So AB by B minus A. In the same way, if he gives any cylinder, two cylinders outside and inside, special cases and case 1, case 2. The same way, if he gives two cylinders, okay, with a different radii, outside one is B, inside one is this radius is A, and this radius is B. This is outside radius and this is inside radius, and for example length is given as some say L, capital or small l. Okay na? Here also same thing and a positive charge. And one more thing here, please make a note, outside is earthed, please. Outside is earthed. Okay, so here also outside is earthed. Clear? And this is positive charge cylinder. Outside is positive charge and here negative. Here also negative, positive charge and negative charge, please. Okay, this side positive, negative, positive, negative. In such cases also you can use the formula as like this. For this cylinder, capacitance of the cylinder, if two radii are given A and B, take as a formula 2 pi epsilon naught L, small l or capital, log B by A with base C. Log B by A with base C. L is the length of cylinder, B and A are the radii outside and inside of the given cylinder, please. Okay, please make a note. Same thing again, positive charge and negative charge is given here. This is positive charge and this is negative charge. Okay, this cylinder is positive and this is negative charge is given. Clear? So these are special cases. Please try to remember these formulas. If at all, if they given examination, 2 pi epsilon naught length of the cylinder by log of B by A with base C. Clear? Right? Let us go to the next one now. These two are special cases. Okay? Right. Now, after knowing about the special cases, now we are entering into the nice interesting topic, that is capacitors in series and parallel connections. Capacitors in series and parallel connection. I am telling you, I am not concentrating mainly on derivations. I am telling you mainly on numerical problems. So derivations mee kosam nenu cheyanu. Just I am drawing the figures and explaining. Okay? Because I told you just mainly you are concentrating in M set, please. So series connection alaga, suppose of single capacitor ichadu. Single capacitor lo plus or minus charge will be going. Same charge is coming. This is single. If number of capacitors are given, number of capacitors more than n capacitors, okay, then you can see plus plus minus minus plus plus minus C1, C2, C3 plus minus, okay, voltage. Here what happens, see, same Q, ante series lo charge is constant and V potential varies. These points you have to remember. Charge is constant, potential same charge is distributed here, but potential మారిపోతుంది ఇక్కడ V1, V2, V3. So V is distributed as V1 plus V2 plus V3. So you can apply the formula in series connection, getting as 1 by C is equal to 1 by C1 plus 1 by C, opposite of resistances. Resistance లో series connection లో plus వస్తుంది summation. దానికి రివర్స్ అంటే parallel series to series parallel form will be getting in capacitance. So 1 by C is equal to 1 by C1 plus C3 plus dot dot dot. If 2 are given, you can use this formula, easy formula, C1 C2 by C1 plus C2. Only for 2. Other case you have to find the LCMs like this. If 2 are given, C1 C2 by C1 plus C2. Please make a note, in series connection, charge is constant, potential varies as V1 plus V2 plus V3. And you know the formula, Q is equal to CV. So Q by C is equal to V. So use this formula here, Q constant, Q by C is equal to V1. Q and ఎంత అవుతుంది? Charge Q by C1. అలాగే Q by C2, Q by C3. Like that you can derive for IPE. But you remember this formula, in series connection for 2 అయితే C1 C2 by C1 plus C2. Number of అయినప్పుడు 1 by C1, go for LCM. Okay? Q is constant, V is varying. Now let us go fastly for parallel, because these are very easy. Again you will study in current electricity also same thing, but in reverse order. Parallel series, series parallel. Parallel కి వచ్చినప్పుడు కనెక్షన్ చూడండి ఏమవుతుంది. See, in parallel connection, capacitors సింగిల్ అనుకోండి, చూడండి ఎలా ఉంటుంది. ఇది సింగిల్ as usual. Q is going C. Now in parallel you can see number of capacitors plus plus minus minus C1, C2, C3, like that so many will be connecting. These are parallel connection. See, in parallel connection, if you observe C1, C2, C3, plus plus minus, plus plus minus, whatever charge is going here, the charge is distributed here, please, as Q1, Q2, Q3. Again, they comes here as Q1, Q2, Q3 as again charge. And ఇక్కడ ఏమవుతుంది, charge is distributing as Q1, Q2, Q3, and V is constant. Potential is constant in parallel. So we know already Q is equal to CV. See, either you can use small letter or capital letter, whichever you're feasible, you can use that letter. So Q ఇక్కడ మారుతుంది కాబట్టి చూడండి, Q is equal to C into V అవుతుంది, V constant. So C1V. ఓకేనా? ఇక్కడ ఏమవుతుంది, Q మారిపోతుంది కదా, Q1 is equal to C1V, అలాగే Q2 is equal to C2V, అలాగే Q3 is equal to C3V. But what is Q? Q1 plus Q2 plus Q3. So CV is equal to C1V plus C1. ఏది మారుతుంది ఇక్కడ మనం చెప్పాను, ఇది ఈ పాయింట్స్ మొత్తం చాలా ఇంపార్టెంట్ అండి. ఇక్కడ చార్జ్ ఈజ్ వేరింగ్ అండ్ V is constant. Charge is varying. ఓకేనా? Q is equal to CV లో charge varying. Q1, Q2, Q3, so on and so forth. And what is constant? V is constant. So in single box contain the charge Q is equal to CV. Q is equal to CV. ఈ బాక్స్ ఎంత అవుతుంది charge? Q1 is equal to what? Q1 is equal to C1V. అలాగే C2V, అలాగే C3V. If you take common V on both sides, what happens? C is equal to sum of all the values. So here you are getting more value in effective capacitance. అంటే if you want more value for capacitance, go for parallel connection, because effective value is equal to C1 plus C2 plus C3, so on and so forth. If you want less value, go for parallel connection, because 1 by C1 plus 1 by C2, C3, so on and so forth. This is the difference between parallel and series connection. And quite opposite to this one in current electricity resistors. అక్కడ series parallel form, parallel series form లో వస్తుంది. Please make a note. Just now I am telling you, in parallel connection, charge changes, potential constant. In series connection, charge constant, potential varies. Please make a note. These are very, very, very important in solving the problems in advanced levels. Okay? Now let us go to a small numerical and try to solve it fastly. Examination లో ఎక్కువగా వస్తున్నాయి numerical capacitor లో numericals. See, this is a very famous problem actually, very familiar, and you have to know how to solve these problems in the examinations. See, they are given like this continuously. C, same value of capacitance or capacitor, and they are giving some connection here like this as some PQ, and మధ్యలో వైర్లు కూడా కనెక్షన్ పెట్టారు ఒకటి like this. One is connected in this fashion and another is connected in this fashion, like this. Now the question ఏంటో తెలుసా మీకు numerical లో? Solve the effective value between P and Q. Okay? That is effective value of capacitance between P and Q. PQ మధ్యన ఎఫెక్టివ్ వాల్యూ అడిగాడు. ఎంసెట్లో కానీ నీట్లో కానీ దీస్ ప్రాబ్లమ్స్ అడిగితే చాలామంది చేయలేకపోతున్నారు. బట్ ఐ టెల్ యూ ఇన్ సింపుల్ మెథడ్, దట్ ఈస్ పొటెన్షియల్ మెథడ్. సో పొటెన్షియల్ మెథడ్, ఇఫ్ యూ అప్లై ద పొటెన్షియల్ మెథడ్, ఇట్ ఈస్ వెరీ ఈజీ. ఎలా చూద్దాం ఒకసారి. సో ఇలాంటి ప్రాబ్లమ్స్ నేను ఏం చేస్తాను, పొటెన్షియల్ మెథడ్ అప్లై చేస్తాను. ఉదాహరణకి ఇక్కడ P పాయింట్ ఉంది, మధ్యలో ఇఫ్ ఎనీ రెసిస్టెన్స్ ఇస్ దేర్, any conductor is there, inductor is nothing is there. So same potential will be here, P. Now wire is again extending. Anything is there, obstruction, nothing is there. So again up to here same potential. Okay. Now coming to here, Q is there, potential. Here nothing is there, obstruction, same Q. Again wire is extended up to here. So here also Q. Now see how many points are there? PQ, PQ, PQ. So there are only 2 points. అంటే ఒకటి P, ఇంకోటి Q. That's all. No more points. So this method if you adopt, you can do any number of problems. P, Q. రెండే పాయింట్స్ ఉన్నాయి. Now observe here. P, Q. P, Q మధ్య ఎన్ని ఉన్నాయి? కెపాసిటర్ ఒకటే ఉంది. So between P, Q, one capacitor. See? Over. This is completed. Now again between P, Q, one more capacitor. P, Q and maro capacitor. This is also over. Again P, Q machine maro capacitor. One more capacitor between P, Q. See. Over. Now observe careful. All the 3 are in parallel connection. Parallel connection ఏమవుతుంది? కలిపేయడమే. ఓకే, ప్యారలల్ కనెక్షన్ కదా. చూడండి, ప్యారలల్ ఏమవుతుంది? C1 plus C2 plus C3, that is C plus C plus C, 3C. జస్ట్ నో ఐడోలి ప్యారలల్ ఏం చేస్తారు? ప్యారలల్కి ఆ ఫామ్లో వేయకూడదు, రెసిస్టెన్స్ ఫామ్లో, రివర్స్ ఇది. ప్యారలల్లో సిరీస్, సిరీస్లో ప్యారలల్ ఫామ్. సో సి దీస్ 2 ఆర్ ప్యారలల్. అగైన్ మొత్తం 3 కూడా ప్యారలల్ ఉన్నాయి. ప్యారలల్ ఫామ్లో ఏంటి? ఎఫెక్టివ్ వాల్యూ C1 plus C2 plus C3, C plus, so 3C is the answer, effective value. So like this you have to solve these type of problems. Clear? Right. Shall I give one more problem to understand better? So series అనుకోండి, మళ్ళీ మారిపోతుందండి. సిరీస్లో 1 by వెళ్ళాలి. You have to go 1 by LCM, 1 by C1 plus 1 by C2 plus 1 by C3. Okay, I'll give one more typical problem, and with that we'll go for the next item. Wheatstone bridge also in this one you are having. ఇంకొక ప్రాబ్లం ఇస్తాను మీకోసం. సెకండ్ ప్రాబ్లం ఏంటంటే చూడండి జాగ్రత్తగా, సేమ్ అదే మోడల్లో ఉంది, కొంచెం వేరియేషన్. 1 కెపాసిటర్, సెకండ్ కెపాసిటర్, థర్డ్ కెపాసిటర్, 1 2 3, fourth capacitor, fifth capacitor. Let me count 1 2 3 4 5. Last one, sixth capacitor. So he has given so many capacitors, and make a note, in such cases all the values will be given same values please. And the points are also given as, for example this one P అనుకుందాం, Q ఇచ్చారు 2 ends. అంతేకాకుండా he has given some more wire connections between these two. One wire is there. Okay, and between last 2 before, ikkada one more wire is there on the top. Last 2 before here, one more wire is connected before. Now inkoti what is said, one more is there between this and these 2, I think. Ekkada ichadu, between the second middle, and after that 2 capacitors, third one ivi ekkada. So this is the connection, is a typical connection ichadu ikkada. Now he is asking you effective value of C between P and Q. Find the value of effective capacitance between P and Q. See, even though it is looking very big, I told you just now, potential method. If you go for potential method, easily you can solve. Entadi chudandi, P, nothing is there, again P, again same wire, P. Okay, clear? Now coming to Q, obstruction is there, so you cannot put the value here. Now the point is, what about this wire and this wire? This wire is continuously running, you can see. Nothing obstruction is there. So you can give some name. I'll put some name as Y potential. So Y continues, again Y, again continues running Y. Now if you observe carefully, there are only 3 points, P, Y and Q, that's all. See, P, Y and Q, 3 points are there. Otherwise the point of ఈ వైర్లో nothing is there obstruction, that is why continues, the potential continuing. If any obstruction there is a potential drop. So 3 points have named P, Y and Q. Now it is easy. So check cheskondi. Between P and Y, capacitance 1. Between P and Y, C. This is over. Even the complete I am rounding up. Next again between P and Y, 1. Another capacitance between P and Y again. This is also over. Again P and Y. Again P and Y. Again P and Y. Again C. Over. Now coming to here, please make a note. Ikkada potential same ga undi. Are you following here? Ikkadaithe manaku madhyalo capacitance vachayi, link marindi chudandi. Okay. Ikkada you can see same potential. So what is the potential difference? Delta Y is equal to 0. So when potential difference is 0, what is Q? Q is equal to CV. So Q is equal to 0. So these two ways there you can delete. See here and here same potential. See same Y is running here. So the potential difference between these 2 points is 0. Charge ikkada flow avudhu inka. Now coming to last one, Y and Q. Go Y and Q. One charge. Have you understand this point here? Understood? ఈ రెండు పొటెన్షియల్ సేమ్ లెవెల్లో ఉన్నాయి. వాట్ పొటెన్షియల్ డిఫరెన్స్ 0. సో ఇక్కడ అంతా వేరియేషన్ ఉన్నాయి చూడండి. ఇక్కడ వేరియేషన్ ఉన్నాయి. PY, PY, PY. So there is potential difference. But here same potential is there. So 0 potential, charge is 0. So you can delete these two. So last law between Y and Q, this thing, C. Now చూడండి, all these three are again parallel. Parallel ఎంత అవుతుంది? Add up. 3C. And this is series. Series formula ఏంటి? 3C into C by 3C plus C. That is 3C square by 4C. What is the answer? 3 by 4C. So this is how you have to get the effective value. అదవుతుందా? ఈ మూడు ప్యారలల్. యాడ్ అప్. ప్యారలల్కి చెప్పాను కదా ఫార్ములా యాడ్ అప్. C1 plus C2 plus C3. 3C. దీనికి సిరీస్. C1 C2 by C1 plus C2. So 3C into C by 3C plus 4C. C cancel. 3 by 4C. So like this you have to calculate in MSET or NEET problems. This is a very easy method called as potential method. You can adopt and easily can solve the problems. Clear? Now in the same problems, if you continue, sometimes they are giving Wheatstone bridge problem also. Of course it is coming in next chapter, current electricity. Wheatstone bridge, VSB. దీన్నే Wheatstone's bridge problems. Actually this chapter comes in the next one, current electricity. But anyhow, ఈ Wheatstone bridge లో ఒకటే గుర్తుపెట్టండి, చిన్న టెక్నిక్ చెప్తాను మీకు. 5 ఉంటాయి మొత్తం, రెసిస్టెన్స్ అయినా చార్జెస్ అయినా 5, maximum 5 charges or 5 resistors will be given in this form. In this form will be giving. See, like this. So immediately you have to understand. అంటే డైరెక్ట్గా వెళ్ళే అవసరం లేదు. You may be give continuous like before problem. You have to convert into that fashion. See, ఈ విధంగా అవ్వచ్చు. 1, 2, 3, 4, 5. You can see P, Q, R, S or something this one M. In such cases what you have to do? You have to check up Wheatstone bridge formula. P by Q is equal to R by S. Then if the bridge is balanced, there is no charge flowing in the middle, galvanometer. There I will be telling you, explaining this derivation in current electricity next chapter. So when the bridge is balanced, for example here 1, 2, okay, here also 1, 2. So P by Q ఎంత అవుతుంది? 1 by 2 is equal to R by S, 1 by 2. So in such cases what happens? You can delete the middle one, and these two are in series, these two are in series, again both are in parallel. Like that you can calculate. So in such cases, if any problem is coming in the examination, you can take it as a Wheatstone bridge problem. Okay? You can take it as a Wheatstone. And you have to first of all check up the values. P by Q, R by S సమానం అవుతుందా లేదు. ఇక్కడ చూడండి 1, 2, P by Q 1 by 2, R by S 1 by 2, balance. Then you can delete the middle one. దీస్ టూ ఆర్ సిరీస్. అదే కెపాసిటర్కు సిరీస్ ఫామ్లో ఏమవుతుంది, C1 C2 by C1 plus C2. అలాగే సిరీస్ C1 C2 by C1 plus. Again parallel, both add up, effective value. Clear? So like this you have to understand regarding the next type of version problem, Wheatstone bridge problem, and you have to check up whether it is Wheatstone bridge or not. Otherwise please you can't put this formula. If both are not balanced, P by Q, then you have to go for different methods. I'll tell you when I'm telling in current electricity there is a procedure, okay? But maximum 99% the balanced bridge only will be giving in the examination, okay? Right. And sometimes for your confusion they may give in this fashion also, Wheatstone bridge. ఒకసారి చెక్ చేసుకోండి. Wheatstone bridge నే మీకు రివర్స్లో ఇస్తాడు కదా, మీకు కన్ఫ్యూజన్ ఎలా అంటే, see, this is one capacitor, this is another capacitor, second one, this is another capacitor, third one, okay? And between second ఒక లింక్ పెడతాడు, that is one capacitor like this, and that will be linked to the like this, and ఇంకొకటి between the first one and second. So like this, ఈ విధంగా కన్ఫ్యూజ్ ఇస్తాడు మీకు ఎగ్జామినేషన్లో. చూడండి ఇక్కడ ఈ పైన ఒకటి ఇస్తాడండి మళ్ళీని. See, these are the capacitors. చూడండి ఎన్ని మొత్తం 1 2 3 4 5. ఇక్కడ లింక్ పెడతాడు, ఇక్కడ లింక్ పెడతాడు. ఇది సపోజ్ P అనుకోండి, ఇది Q అనుకోండి. Clear? Now he will be asking you, okay? He will be asking you effective value between P and Q. Effective capacitance between P and Q. Okay? ఇది కూడా సపోజ్ సేమ్ వాల్యూస్ అనుకోండి. And this one you have to rearrange. మళ్ళీ ఇలా చూసి మీరు డైరెక్ట్గా Wheatstone bridge అనొచ్చు, బట్ అగైన్ యూ హ్యావ్ టు రీఅరేంజ్, యూ హ్యావ్ టు సాల్వ్ ఇట్ ఇన్ సింపుల్ మెథడ్. ఎలా చూడండి, P వస్తున్నాడు ఇక్కడ, అడ్డు లేదు, సో ఇది PA. Now it is going, capacity is there, that means there is obstruction, you cannot go again, you cannot take same value here as you have done in before. Now again, now Q is there, here Q potential, but when you are going, capacity is there, you cannot take the same value. So here you have to change some names, one is P, another is Q. What I'll do is I'll put some names. This point I'll put it as M, this point I'll put it as N. Clear? I'll put this point as M, this is N, and already Q, P, P. Now you observe carefully, this is coming to Wheatstone bridge. See here, this is coming to Wheatstone bridge. Can you understand? See, P, M, N, Q. See, it happened to be Wheatstone bridge here between P and M. Between P and M. See, between M and N. See, between N and Q. Between N and Q. See, okay, between N and Q. Next, between M and Q. Between M and Q. Then the N and sorry, the N and Q. The N and Q. N and Q. See, M and Q. M and Q. See. ఇంకేమి లాస్ట్లోనే ఇదిగోండి P and N, P and N, ఇదిగో P and N. Clear? See, 1 2 3 4 5 Wheatstone bridge. So suppose he has given all the values same as in this case, P by Q is equal to R by S, C by C is equal to C by C. So equal to 1 is equal to 1. Middle one is balanced, you can take it away. So these two are in series. Again these two series. So series connection ఏంటి? Same value C1 C2 by C1 plus C2 C by 2. So ఈ value effective value ఎంత? C by 2. Same value here also having C by 2. Again these two are parallel again. So what happens? C by 2 plus C by 2. C value. So like this, complicated problems also you can solve by using potential method. Even if he gives the in the form of Wheatstone bridge or not in a Wheatstone bridge form, in different form. So like that, you have to solve these type of complicated problems. Okay. Now what I'll do is, still some more is left over. More. So what I'll do is, the remaining part, I think only another half part కాదు, ఒక 5 to 10% part is left over. That is ladder problems. So ladder problems, battery, polarization, okay, all those left over. So what I'll do is, I will tell all those in next part. Fifth part, I'll extend it to fifth part. Now this is fourth part of electrostatics. In fifth part, I'll be telling those remaining part. Okay, right.